This is my unit 1 test correction, and I got 23 out of 35. Got number 3 wrong, and in this question, the answer is C. And how I got that is by using this formula. And the question says that an object is released from rest, so we already know that the initial velocity is 0. So it eliminates this part of the equation, and we get this. Now, it wants the distance traveled during the next second of time. So we plugged in 2 for t, which is time, and it's squared, so that become 4h. And it says that in the first second of time, it follows the distance of h, so subtract h from 4h and we get 3h. So let's see. And number 10, it's asking about the signs of initial position, initial velocity, and acceleration. And the initial would be negative, since initial position is negative 5 meters, and it's moving away, so that's negative velocity. So then it's slowing down, so acceleration has to be the opposite of velocity. So I guess that's why it's slowing down. So it's B for 10. What the hell? And 11, we use the same formula from number 3, which is this, but now we use this part only. And once, or it's asking how far from the base of the cliff would the diver have landed. The diver initially had been moving horizontally with a speed of 2v, and it would be 2d, because on first speed was d, and second time it's just 2d, which is double. So we double d as well, so we get 2d. And you just plug in this thing too, you get the same thing, 2d. Alright. And for the FRQ, free response questions, and part C, I got 1/2, but the right answer is, okay, can you see? A equals 2v squared divided by d. And my mistake here was I forgot to distribute the 2 to vt, velocity for truck. And yeah, it showed that. Boom. Then it simplifies to this. Since 2 goes to this 2, eliminates that, then 4 becomes 2. You get that. And for D, you said just use your graph. And let me read the question. Express your answer in terms of TD, just for an answer. Determine the time which the speed of the car is equal to the speed of the truck, which is VT. And the speed of the truck and the car is the same at beats at 1/2 t, 1/2 d. So they're the same, or the speeds of the car and truck are the same at t equals 1/2 td. Yeah. And then the last one that I did not do. Alright, part 2 of the FRQ. Part 2b wants me to explain how the motion of the rock on the Earth would be different from its motion on planet X in terms of maximum height above the ground, the speed at which it reaches the ground, the time in which it is in free fall, and its acceleration due to gravity. On Earth, the maximum height of the rock that it get would be less from planet X, since it's experiencing a greater force downwards. So 15 meters to 0 meters would go faster, or come faster. So it'll come to a stop, or 0 meters per second faster, meaning its maximum height will be shorter. Oh my god, will be shorter because of the greater acceleration, downward acceleration. And then for the speed at which it reaches the ground on Earth, it would also be faster, and the time it is at free fall would also be shorter, faster and shorter, because of the greater gravitational acceleration. And the last part, and its acceleration due to gravity, it would be greater since it's negative 9.8 meters per second downwards, compared to planet X, which is negative 5 meters per second squared. What? No, let me restate that. Because on Earth, the gravitational acceleration is 9.8 meters per second squared downward, and for planet X, it's 5 meters per second squared downwards, and 5 is less than 9.8. So, acceleration due to gravity on Earth would be greater, meaning that the rock will spend less time or a shorter time in free fall on Earth, and the speed which it reaches the ground would also be faster since it spends less time in free fall. And the maximum height would be shorter since on Earth it has a greater acceleration and it'll decelerate faster, so it'll travel a short distance before it starts going back down again. That's that's that.